Hello friends, welcome to another video on fundamental biology. So in this series of video, we are talking about some basic concepts related to plasma membrane as a part of 9th standard CBSE topic, the fundamental unit of life. So we have already had some discussions regarding solution, hypotonic, isotonic, hypertonic, exosmosis, endosmosis. So viewers, those who haven't watched those discussions, so kindly get back to those videos and then join us here. Today's discussion is going to be more or less continuation of the previous discussion on exosmosis, endosmosis. So let's get into the video. Now, here you have three solutions as described in the previous discussion. You have got an hypotonic, isotonic and hypertonic, and we are going to place a cell. So here we expect endosmosis to happen. So what is endosmosis? Gaining of water inside the cell. Okay. So let's assume that this cell is going to be a plant cell which has got an outer cell wall. This is going to be the plasma membrane. So this is a cell wall, this is the plasma membrane, and this is going to be the protoplasm inside. Hope you get this picture. Now what happens? There is going to be a gain of water inside. So what happens normally when there is an inflow of water inside the cell due to endosmosis? The cell is going to swell up, cell is going to bulge. So you call this as the cell as a turgid. So this is a term which I wanted to insist here. Okay, you call this cell as a turgid. And one more thing to be noted, okay, one more point or two terms to be noted here is, what happens when cell starts gaining water, you get this plasma membrane will be extended. We call this as the expansion of the protoplasm. Protoplasm is nothing but the cytoplasm and nucleus, okay, excluding the wall. So this expanding plasma membrane is going to exert a pressure on the cell wall. I hope you get this. So this pressure is what is called as a Turgor pressure. Okay, Turgor pressure, and in turn the cell wall is going to exert an equal pressure on the plasma membrane, which is what is called as wall pressure. So we have got two terms here, Turgor pressure and wall pressure. Okay, there is no much discussion further on Turgor pressure and wall pressure. So we will have we will carry out this discussion in 11th standard level. But in 9th standard, just knowing the terms, okay, Turgor pressure, wall pressure is fine, and you should know why the cell is called as a turgid. So this is what is going to happen when a cell is placed in a hypertonic solution, right? Now let's come to the hypertonic solution. What happens? You expect a process called as exosmosis. Okay, so based on our previous discussion in the previous video. So let's take a cell. Okay, now the cell is going to lose the water. You call this as an exosmosis, lose the water. Now what happens is, you get a cell with a somewhat of a shrunken protoplasm. Hope you get this picture. Shrunken protoplasm because cell is losing water. Now you call this process as plasmolysis, and the point to be noted is, since there is no water, no Turgor pressure. So plasmolyzed cell will not have Turgor pressure, right? Because cell itself has lost the water, there is no pressure exerted by the plasma membrane on the cell wall. Okay, one thing. Second thing is, when you place this plasmolyzed cell back in a hypertonic solution, the cell is going to gain water and become turgid, right? You call this process as deplasmolysis. Okay, so in case if you haven't got these concepts on the first go, so kindly think about it, and in case still a confusion is there, kindly intimate in the comment section or do mail us, right? So point is, deplasmolysis, that is the cell, plasmolyzed cell getting back the water can happen if a plasmolyzed cell is placed in a hypotonic solution, right? So this is another point, plasmolysis and deplasmolysis. And third thing is, you see this plasmolysis can happen only in plant cell. This is an interesting concept. Animal cell doesn't have the cell wall, right? So it is going to have only the plasma membrane as the outermost membrane. So whenever it's going to lose water, the entire cell will be shrunken and the cell is lost. So plasmolysis as well as deplasmolysis is possible only in plant cell, not in animal cell. Okay, these are also important points to be discussed in this this section. Whereas in isotonic, what is going to happen? The cell is neither going to take water, or it is neither going to lose water. Okay, that's what we have discussed, which means that there is no net movement of water as we have seen in previous case. So what happens here is the cell is going to have a normal amount of water, so it is neither plasmolyzed nor turgid. So here the turgor pressure is not sufficient. See, the cell is going to have only the normal amount of water, so no extra water for the turgor pressure to develop. So as we have seen, there is no plasmolysis, there is loss of water, nor the cell becoming turgid due to gain of water. So you call this cell as a flaccid cell. Okay, you call this cell as a flaccid cell. So in short, when we place a cell in a hypertonic solution, the cell becomes turgid. When we place a cell in an hypertonic solution, it becomes plasmolyzed. When we place a cell in an isotonic solution, it becomes flaccid. Right? So this is the point, okay, to be noted. Thanks for watching, and let's meet in another interesting concept in another video. Okay, thank you so much.